Hello, and welcome to another APCS Principles daily video. In today's video, we're going to talk about undecidable problems. My name is Mrs. Julie Alano, and I teach at Hamilton Southeastern High School in Fishers, Indiana. In this video, we will investigate the existence of undecidable problems in computer science. So what exactly will we learn today? As I said in this video, we're going to explain the existence of undecidable problems. So here are some essential knowledge statements. It tells you a little bit more about what a decidable problem is and what an undecidable problem is. So a decidable problem is the number even, but an undecidable problem is a problem where you can't always come up with a yes or no answer. And an undecidable problem may have some instances that have an algorithmic solution, but there is no algorithmic solution that could solve all instances of the problem. So let's take a look at an example. So here is a decidable problem. A decidable problem, again, is one that we can come to a yes/no answer given any input. An example would be given a number, determine if it's divisible by 3. We know that the algorithm below would provide the correct output every time. So we have a procedure here that's called divisible by 3, which takes the number and mods it by 3 to see if that's 0. Remember, mod gives you the remainder of the division. So if a number divided by 3 gives you a remainder of 0, then we know it's divisible by 3 and we will return true. Otherwise, we will return false. So that's an example of a decidable problem. So how about an undecidable problem? Here is an example of the halting problem. The halting problem is defined as, given an arbitrary computer program with given inputs, will the program stop or will it run forever? If you have worked with loops, then you probably have run into a program that doesn't stop. There is no way to solve this problem with a yes/no answer every time. How do you test for an ending if there is not one? And that's what happens when a program runs forever. There is no ending. One way would be to test for an ending. But what if that ending is not easily found? What if it takes an unreasonable amount of time to find the ending? So if we have a program that actually does end, but the ending takes way too long because the program runs for an unreasonable amount of time, is that because there's an end or does one not exist? So it is difficult to determine because of the fact of unreasonable amount of time. So if we try to determine if the program ends, what if we can't? Do we know that there's an end or do we not? So you see where the problem comes in. This is an undecidable problem. There is no algorithm which can always produce a yes/no answer for every input of the problem. So we can't always determine, will the program end or will it run forever? So where have we seen this in computers today? When a website or program takes too long to load, it may never load or it may just be taking too long. Either way, after a certain time, a computer decides the program should be stopped and gives you a warning or gives you an error or tells you, hey, this website's taking a long time to load. So when is that algorithm isn't determining if it will ever find it or ever load. It's just determining, hey, after a certain amount of time, I'm going to stop trying. And so that's where we kind of seen this problem in today's computers. So let's practice. Let's take a look at a couple questions. Here's our first question. If you'd like to pause the video before I go over the answer, you can do that now. So, true or false? An algorithm can be used to solve an undecidable problem. The answer is false. If the problem is undecidable, then there is no algorithm which will come to a yes/no answer for all inputs. Here's another one. Again, if you'd like to pause the video before I go over the answer, you should do that now. True or false? If a programmer encounters an undecidable problem, they can just use an algorithm that works most of the time. The answer here would be false, because an algorithm that works most of the time doesn't cut it when it comes to trying to solve a problem. So if a programmer encounters an undecidable problem, they will need to come up with another way to decide what to do with the problem, because an algorithm that works most of the time is not a good way to go. So again, what should we take away from this lesson? We determined that there are undecidable problems in computer science, and we were able to take a look at what a decidable problem is and an undecidable problem, and determine that an algorithm cannot be, if there is no algorithmic solution, then to solve all instances, then it is an undecidable problem. Thank you. Have a great day.